All right, let's just get right into it. Welcome to this explainer where we're jumping straight into the high-stakes cyber landscape of the Cambridge IT 9626 exam. Today, we're basically going to completely upgrade your answering algorithms. We are totally leaving behind that dry, rote textbook memorization, and instead, we're looking at exactly how to construct the kind of answers that examiners absolutely love to reward. Seriously, if you ever felt like you totally knew the material but still somehow dropped marks, you are in exactly the right place. So picture this. We're looking at a super confident student sitting in the exam hall. They're furiously writing down what they think is an absolutely perfect answer about computer systems or data security. They finish their thought, put the pen down, and boom! Internally, a massive, glaring red error overlay just flashed in the examiner's system. 9 out of 10 students actually get these core syllabus questions wrong in the exact same way, and it quietly costs them their grade. Let's look at this mistake so you can avoid it entirely. Okay, look at these two approaches side by side. On the left, we've got the flawed answer. Encryption keeps data safe. I mean, it sounds true, right? But this generic statement literally bleeds marks. Now check out the top band answer on the right. Encryption scrambles payroll records so unauthorized users cannot read sensitive data if intercepted. Boom. That right side locks the marks in because it uses precise, scenario-specific anchoring. The examiner doesn't just want proof that you've memorized a glossary. They want to see you apply a hard technical concept to a real-world scenario. So how do we rebuild that flawed answer into an absolute masterpiece? Well, we're going to deploy what I call the examiner's blueprint. Specifically, it's this 5-phase framework called PEEL-J. That stands for point, evidence, explanation, link, and judgment. You start out by making a super clear claim. Then you back it up with actual technical detail, explain the underlying mechanism, link it straight back to the scenario, and finally, evaluate it against alternatives. Once you see exactly where the errors usually creep in, using this structured method becomes basically second nature. As you're checking out this full-screen breakdown of the framework, I really want you to zero in on the link and judgment steps over on the right. This is where the magic actually happens. It's where your technical explanation anchors directly back into whatever real-world scenario they threw at you in the exam prompt. Because think about it. Without that link, you're just reciting random facts. With it, you're actually solving a problem. But wait, there's another layer to this. Alongside PEEL-J, you've got to run your knowledge through what we call the 4-prompt mechanism. This is going to guarantee your answer has maximum technical depth. Before you write a single word, just ask yourself these 4 things. What is it? Like, define the term. How does it work? Explain the actual algorithmic logic. Where is it used? Pinpoint the practical workplace context. And finally, why this choice? Contrast it against the alternatives. Look at how beautifully this structure systematically diagnoses exactly what an IT question is demanding from you. It maps out the path from just giving a generic revision answer on the left all the way up to high-mark problem solving on the right. By forcing yourself to hit what, how, where, and why, you completely bypass that classic trap of giving a vague definition without any real-world application. Okay, let's actually take this blueprint for a spin on a core syllabus topic, communication over data streams. And we'll kick it off with the essential rules of netiquette. Netiquette, which is just short for internet etiquette, is basically the practice of showing common courtesy and using non-inflammatory language in online communications, like your emails or forums. Since you can't see facial expressions or hear tone of voice over a screen, being remarkably clear is absolutely crucial to stop misunderstandings before they start. You've got your core rules right here. Don't send spam. Definitely avoid using all caps because everyone just reads that as shouting. Respect people's privacy. Always double-check your spelling and grammar to keep things professional. And obviously, do not plagiarize. But here's the really crucial takeaway. An examiner isn't just looking for you to parrot this list back to them. No way. They want to see you use that PEEL-J framework to explain why these behavioral protocols matter so much in a text-only space where body language is completely out of the picture. Now, obviously, just being polite isn't going to stop the actual bad guys. We also have to actively defend our networks against automated threats, and spam bots are a huge one. Spam is just unsolicited email, and spam bots are the software designed to aggressively harvest email addresses from all over the web. They build these massive, bloated mailing lists just to flood networks, instantly drain your network bandwidth, completely clog up inboxes, and, a lot of the time, distribute some pretty nasty malware. When we're talking about securing these digital streams against those kinds of threats, you absolutely have to distinguish between the types of attacks. It's a key distinction. A passive attack is a breach where the system itself isn't actually harmed, but messages or data, like a password sent over email, are intercepted and read by someone who shouldn't see them. An active attack, on the other hand, is when someone is actively altering or harming the system itself, like dropping a destructive malware payload that wipes out files. And that brings us to the ultimate defense mechanism against both of those types of interception, encryption. But listen, falling into the vague wording trap here is a totally fatal error for your exam score. Look at the red stop sign on this slide. Examiners will actively penalize you for just writing out lists of undeveloped points. You've got to name the technique and flawlessly explain its mechanism within the exact context of the prompt. Want to know the absolute biggest pitfall? Confusing encryption with authentication. Do not mix these up. Proving your identity is authentication. Scrambling data for secrecy is encryption. Always make sure to highlight the core mechanism. Encryption doesn't just keep things safe. It mathematically scrambles the data into a completely unreadable format. So even if it gets intercepted during a passive attack, it's totally useless to the attacker. Now, taking it a step further into specific encryption protocols like TLS and IPsec, things get even more precise. To avoid getting your wires crossed with the terminology, check out the examiner alerts on this full-screen guide. Students constantly mix up cause and effect here, or they completely fail to explain how a protocol actually delivers a specific security outcome in the provided case study. You have to tailor your answer to the scenario. All right, pop quiz time. Let's see if this is sticking. Check out this glowing stream of text. It's a fresh, massively flawed exam answer. TLS is good for security because it encrypts things and prevents hackers. IPsec is also secure. I mean, it really sounds like something a student might quickly jot down when they're rushing the clock, right? I'm giving you exactly 10 seconds on the clock to spot the critical, examiner-noted failures in this data packet. Think back to the PLJ framework. Think about that four-prompt mechanism. What is missing here? Clock is ticking. And time's up. Look at the red pen markings on the bottom left. You can see exactly why an answer like that would only pull a 4 out of 10. Encrypts things? Super generic. Prevents hackers? That's cause and effect confusion. It completely lacks any syllabus-specific terminology or real-world context. Now, compare that to the green box on the right. Notice how it correctly identifies that TLS provides transport layer security to protect customer payment details in a specific e-commerce scenario. See the difference? That right there is a top-band answer. So before you ever compile and execute your final answer in the exam hall, you've got to run your thoughts through this full-screen diagnostic checklist. Dissect those command words, classify all the components, and deploy the four-prompt mechanism. Watch out for that generic point trap, and make absolutely sure you aren't blurring the lines between near concepts like encryption and authentication. So, armed with the PLJ framework and the four-prompt filter, you are officially ready to turn basic, rote memorization into undeniable, top-tier exam mastery. That is the true Cambridge IT 9626 methodology. It's about really understanding it, not just memorizing it. So, what's it going to be? The next time you sit down, open an exam paper, and see a massive 10-mark scenario question, are you just going to write down definitions, or are you going to engineer a flawless solution? Keep practicing, and I will catch you in the next explainer.